Welcome back everyone to the Hello World Guide. This is another episode of the Asteroids game in C++ series, and in this video we are gonna use our system of intersection between our bullet and asteroid and kind of refine it further, and we are also going to refactor our code. So we'll first of all begin with the refactoring process. We'll because we are going to have a bunch of different functions for intersecting between like points and polygons and stuff like that. So for this reason I'm going to create a separate let's just say header here called physics.h that will handle all of that. So we'll create a header called physics.h, and this will contain a single namespace called physics.h, called physics, just physics, and it will handle all of the physics related stuff for us. So we'll call it physics, and like that. Even though it's not like a full-fledged physics system, so this name is a bit misleading. You might want to call it collision as well, but let's just call it physics. And we are gonna create a namespace like that, and in here we are going to create a method. We'll create a method that returns a boolean called intersects, and we'll overload this method a bunch of times for different kinds of things here. First of all, we have got like the first method we need is between a point and a actually let me include hashtag include. We are going to include sfml here, sfml slash, let's just include graphics.h. That would include every necessary thing. And the first method, the first overload of the method we are going to create is going to check for the intersection between a point, which will be represented as a vector 2f called point, and another vertex array. So we'll have the vertex array as a const reference. Actually we'll have both of these as const reference, since that is just a better way of passing the values, since it will prevent copying, unnecessary copying, and would prevent bad performance. So we'll because it would not require too much memory. So we'll create a const reference for a vertex array as well, which we'll call polygon. So vertex array, and we'll call this reference over here, and we'll call this polygon. Now this will be the first overload of our method, and I'm going to go ahead and try to implement it in physics.cpp, which we have not created yet. So it does not, it says it has enable, but that should actually create the physics.cpp for us. And if it doesn't, you just create the physics.cpp file. Make sure we include physics.h here, and since it has already copied it for us, we can just paste the thing here. Alright, that's pretty cool. Now let's go under bullet.cpp, and here we have got all of that. So we'll basically copy the whole algorithm, the actual algorithm. We'll copy that, and then we'll go in physics.cpp, and we can paste that here like that. And you can see that well, it gives us a problem about position. First of all, we'll need to find our wherever we've got position, we'll replace it with point in this document. We'll just replace that. Okay, that's quite nice. And we are also going to remove this transform here, and you might be wondering how are we going to apply the transform if we removed it from here. Well, you'll find that out soon enough. So for now I'm going to just remove this here and put this here directly. Actually, another problem, this needs to be positioned. We also kind of changed that. That's wrong. So we'll do this, and afterwards, when we are doing this, we won't actually be checking anything here. Instead, we'll just return this value. So we'll just say return our intersection count, whether our intersection count is odd or not. We'll just do this check and then return it. And yeah, that's pretty much all we need here, and that should essentially do our polygon check quite well. Now the next thing we need to do is change our bullet.cpp to not do any of this, but instead use the intersect check. So I'm going to go here and remove all of this from here. Well, actually, let's first go ahead and we'll remove it afterwards. First, let's go ahead and say physics. For that, we'll need to include physics.h here. So we'll go up here, hashtag include, and we'll include physics.h like that, physics.h. Once we have included that, we'll go down here and we'll say we'll call the intersects method, and for the arguments we'll basically Well, actually it won't work like that. We'll need to say physics colon colon intersect since it's in the physics namespace. So in here you can see that the first argument we are going to just pass in the position of the actual bullet, and for the polygon we are going to pass in our asteroid get vertex array. Now that might seem to work. However, of course the problem is that currently we have not done any transformation at all, and so we need a way to do the transformation as well. For this I'm going to go under physics.h, and let's create another function here that is going to return a const reference to a vertex array. Just it is going to return a vertex array called get transformed. So that should basically transform our vertex array to from whatever space it is, local space to world space. We'll create that, and what that will do is it will take in an argument called, we'll just call it polygon again, and that will return it but transformed to the transform here. For that reason, of course, it's also going to take in a transform. We'll also take that as a const reference, so const sf colon colon transform here, and we'll call that transform. Alright, once we have got that, it should work and it should not give us any errors. Yeah, it does work. We'll implement this in a second. First of all, let's go ahead and actually use that here, for which I'm going to go ahead and say let's move it to the next line so that it does not take up too much space. So we'll say physics colon colon get transformed, and we'll pass in our array's position, and for the transform we'll just pass in our transform that we have calculated here. And actually we have also created a variable for the polygons, so we can pass that as well, and this way we won't need to split it up. I think it should fit on one line. Well, it doesn't, so we'll split it up anyways, but now it is a lot better. And actually let's remove that get vertex array variable, but we will keep transform as a variable because putting that here directly will just overcomplicate stuff. Alright, so with this we can see that we have got our function here done pretty much, and the next thing we are going to do is we need to implement this get transformed here. So I'm going to just say create an implementation, and once we have done that, we are going to create an sf colon colon vertex array here, let's just call it transformed, and in the end we are going to return this transformed. So in the end we are going to just say return transformed, transformed actually, not transformed. And afterwards in here we need to actually go over each of the vertex arrays. So we'll set this equal to our polygon by default, and we need to go over each vertex and then translate it according to the transform that we have got, transform it according to that using the transform point function. So for this we'll essentially go ahead and run a loop like this one. So for like that, we'll copy that, and in here we'll paste it, but the only thing now for that we'll run a for loop here, which will run for our array size. So we'll say transformed get vertex count. So we'll loop over each of the vertex, and we'll say transformed 0 is equal to polygon dot well, actually not polygon, we'll just say we can use the transformed here directly. So we'll say transform dot transform point, and for the actual point we'll pass in our transformed I here, not 0. I actually accidentally used here 0 here. So this will basically go over each of the points and change that change those points to be transformed according to whatever transform we have got. Of course we need to pass this as dot position here, and of course we need to put dot position here as well, because the point actually contains other data along with the position. Alright, so with this we can say that we have got that function implemented as well, and in the bullet now we don't need to do anything too much complicated. We can just use the physics functions here, and those functions are implemented in a separate place, so that's quite neat. Let's run this and see if everything is still working correctly, and hopefully it will be working. So let's run that. You can see it compiles everything, and well, it does give us a bit of a problem actually. I just realized we should not be returning a const reference here, since this is since we are creating like a temporary thing here, so we'll not return that, but instead return a copy here, because we were returning we were returning a const reference to a local thing, and you should generally not return references or pointers to local variables. Even though it's a const reference, we are going to still change it to return a copy instead. Alright, we'll run this now, and hopefully this will work correctly. It gave us a warning, so you should not really ignore warnings all the time. Sometimes they can be ignored, but sometimes you should listen to actually what the compiler is saying. And you can see it still works correctly like it was working in the previous video, and our bullets do get destroyed upon colliding with the asteroid. So yeah guys, that's pretty much it for this video, and I'll see you in the next one, in which we'll start implementing the asteroid side code for handling the asteroid's response on hitting with the bullets, and then we'll implement asteroid collision and also asteroid player collisions using the separating axis theorem. So stay tuned for that. I'll see you in the next video. Make sure to like and subscribe as well, and share this video with other people, and I'll see you in the next one, and bye.